Alright. Let's see. Disable preview. Compile. Open in a debugger. Run. Where are we at? We are at here. Okay, well, let's sort out the camera, which is where I left it. This thing. Okay, so we have this aspect ratio, which I'm just gonna synchronize with camera, I guess, height over width, which I'm gonna synchronize. And we also need the position, float to camera position. There it is. So half span, alright, so position and clip space. Float, so float to camera what? Camera half span is camera half span x, and camera half span x times height over width. Yeah, that should do it. Okay, now we just need to pass this buffer into the shader. Oh boy. Well, so we're gonna need another buffer. I call it, so it's just gonna be one of these. I call it C buffer. I think that works. Call it C buffer. I'm gonna have to create it at some point. Somewhere. Well, anyway, really. Okay, how do we create buffers again? Like this. And we need to be able to, yeah, so we basically kind of need all of this. But like maybe it's different, maybe it's not, let's see. Okay, so the size of the buffer is size of, yeah, well, we're gonna have to copy this, hold on. Well, actually, are we gonna have to copy this? Well, we are gonna have to copy this somewhere. Yeah, we only have one of these, so let's just call it C buffer. Yeah, we're just gonna write all of this in. Every frame, whatever. Yeah. Which, I mean, I suppose we can do it in the same way, right? Where we just kind of map it. Well, I mean, this one we don't need to keep mapped. Because we don't really need persistent storage, although... Do we? Like, should we just keep this in there and keep it mapped? That way it's in one place. Maybe. Maybe. So it's gonna be like that, then. Except there's only gonna be one of them. So there's the buffer, but instead of doing this struct thing, we'll just have C buffer mapped pointer. Yeah, let's try that. Let's try that. Which means that I want to probably pull this out. like this thing. Where is it? Here. So this goes, oh, this goes, this goes out somewhere. Static, void, whatever. D3D11, create mapped buffer, I guess. Okay. Yeah. Okay, description. So I want to call this here. So we want to pass in the size. Which is going to be like an I64 or whatever size. Then it creates it, so we're gonna need the device. Device. And context. Is it device context? Yeah. So there's the device. And this is the sort of thing that we're gonna really return. So what's it gonna return? It should return a buffer and I guess a mapped pointer? I guess D3D11 mapped buffer. So that's what it's gonna return. And here we've got ID3D11 buffer, and void star mapped pointer. Mapped buffer. I think we can simplify this even. Like we could do this, and that should work. Okay, so that is the result. So the result goes in result buff, then we assert, then we map it, which is the result buff, and then we just do this result mapped pointer is, let's say, that. Oh wait, this is it. This is the return value. I thought this was just an empty thing passing in. Okay, well, that's that. Buffer. Mapped is that, and then we just do d3d11 dot rects dot mapped. I mean, map cap is already set, map lang is 0, mapped pointer is mapped pointer. Buff is mapped buff. Yeah, so this one we have to unpack because it's an array. But the other one, I mean, the other one we don't want this to be a void star, so we're gonna have to unpack that as well. Let's see how that works out. Oh. Size of C buffer d3d11 device d3d11 context. Mapped is that, and then we've got what? We've got d3d11 C buffer, buffer is mapped, buffer C buffer, mapped pointer is mapped pointer, mapped pointer. Yeah, I think that works. Well, let's find out. Yeah. Okay, so we're not destroying some of this. Let's destroy some of this. So it's essentially that. So let's destroy it after acts, I guess. Over here. Unmap C buffer. And then we want to release so unmap C buffer, release C buffer. Okay, that worked. Map release. Now, what are we doing? We want to actually write to it. Okay, so we're doing this a fair amount. Is this worth pulling out? Maybe. I mean, it's 2 lines. Nah, it's probably not. Okay, so with keeping camera position, camera half span, camera height over width in there. So I guess like right after here we can just write to it and see if that works correctly. D3D11, C buffer. Mapped pointer, there we go. Camera position is, that's a V2, right? 0, 0. And then camera half span X, let's say 10. And what happened here? Like, what is this? Camera height over width is, well, we have window height over window width, except we want to F32 this, both of these. Okay. We see nothing. We see nothing. Let's see if it's actually coming through in RenderDog. Is there an exception somewhere being thrown? Like, what's going on? Okay, I'm not, I mean, there's these exceptions. But like, so what? I think we've had them before. That's very helpful anyway. So, like, what? Okay, so the debugger is incapable of debugging. Wonderful. I'm not setting this. I'm not setting the constant buffer. Okay, so that is a problem. All right. That doesn't produce any errors or anything. That's perfectly. I just need to know that. So yeah, we do want to unmap it at some point. I mean, I don't know. Like this is where we draw stuff, so we should probably just unmap everything, like up here. And map it back here. Map, context, C buffer, write, no overwrite, and then do one of those. Okay, well, I don't really need this anymore. Okay, so it's being mapped, well, it's being unmapped and then mapped back in. It's being unmapped here. It's not being set though, so... Okay, so let us set vertex buffers. What's the ID3D11 device? Context. Set constant, like what? How do you set constant buffers again in DirectX? Let's see. D3D11 set constant buffer. Oh, there is DS set constant buffers. DS set constant buffers, yeah. Context, PV table set constant. Well, it's VS set on some buffers that we want. Okay, pass the context, and then start slot, number of buffers, and pointer to the first one. Start slot is 0, number of buffers is 1, and the pointer to the first one would be D3, D11, seed buffer, buffer. Okay, there it is. So we've got a problem. A buffer trying to be bound as vertex shader constant buffer did not have the appropriate bind flag set at the creation to allow the buffer to be bound as constant buffer. Okay, I didn't create it correctly, I see. Well, oh, bind flags. Okay, well, what's this? D3, D11 bind flag. I mean, I guess let's do this way. The device const I64 size, and then D3, D11 bind flag. So bind vertex buffer would be one of them, and then bind constant buffer would be the other one. 11 bind vertex buffer, and 11 bind constant buffer. Oh my god. Okay, let's see. Okay, so that launched. I'm still not seeing anything. I don't seem to have any errors though happening. Okay, so is RenderDoc capable of debugging the program? No. Well, let's go to the shader and just set some of this, let's say, camera positions. Where is it used again? It's used there. Can I set it here just as a debugging experiment? Is that possible? Float to the constant. I see. I cannot set anything. Alright, well, let's do it this way then. Let's just like underscore them and then just set them manually here. Camera half span X, let's say that's float. Let's move these here. And set them like float to camera position 0, 0, camera half span is 10, camera height over width, let's say 1. Okay, so that works. Alright, well, what happens if I use the height over width that's past 10? Then it breaks. Okay, well, apparently it's that thing that's it's the real issue. What if I set this to 1 here? Then I can see it. Okay, well, alright. What if I set this to, well, let's first of all, oh, it's 0, isn't it? Because window height and window width aren't updated until until we get in here. So we kind of need to do this every time. Well, camera position is updated somewhere. Half span, it can actually be set here, because that's not going to be updated every time. Position is going to be updated somewhere. Actually, position is going to be updated like probably here, right, in update. So this is like input. Well, I mean this is input and update. It's here. So somewhere in here, camera position needs to be updated. So this is where we just update the window size. So height over width needs to be updated here. Load to F32. Let's say window height over F32 window width. Okay, so that does work out. All right, and we can probably use the proper ones. Okay, is RenderDoc working now? No? What? Why not? Why is it just like, quitting? Like, what is this? There's no errors or anything, it just doesn't work. This works. Why did RenderDoc just stop working? I don't get it. I mean, I can launch the program just fine. Okay, well, I guess RenderDoc doesn't want to be used anymore. Like, this is it. This is it. We're not allowed to debug GPU stuff any longer. We've had enough. We've had enough debugging. It's not necessary anymore. Enable API validation. Well, I mean, I don't think that'll help us. Allow full screen, allow VSync, queue capture, frame 0, like, I don't even... Oh, well, finally we get something out of it. Failed to resize swap chain. Why? What? I mean, it literally just calls resize buffers in here, and like that's it. And it just doesn't work. It only happens when you launch it under RenderDoc. But only if I try to like... Well, I mean, if I try to capture the first frame, it fails. But if I try to capture the second frame, then it does that. What if we don't allow full screen or VSync? Then it just it doesn't create any windows, it doesn't output any error messages. I'm not seeing any diagnostics, it just fails. even though otherwise it works fine. Yeah, there are some exceptions being thrown, but like they always throw, don't they? Or is there a specific place where they're thrown? Yeah, that's not what I said. Okay, there they are. Yeah, I think aren't they thrown just like when you create? Yeah, I think they're thrown like here. Yeah, no errors. And there's the two exceptions. I mean, we can't really do anything about those. Well, I mean, I do kind of want to debug stuff, you know. Can we? Render doc fails to launch process. I suggest logging. How did what? Apparently, there's a debug log somewhere. Can't launch application. Okay, well, I mean, is it something to do with those mapped buffers, or? Can it like attach to a running process, or does it have to launch it? It can attach to a running instance. Well, maybe a little helpful. That is your running instance. Attached to running instance. What is this? What is this nonsense? No, I guess it can't. I mean, it used to be able to do it, and now it just isn't able. Is it because of that? Like, it just doesn't like the mapped buffers or something? Like, it wants the buffers to not be mapped. Well, I mean, I guess if I... Okay. Let's try this, right? We're not gonna map anything. We're not gonna write to it. And then we're not gonna unmap it. And then we're not gonna map it here. Can it to it that no, it just fails. Well, actually this time it makes sense at least. Alright, there is another right in here, isn't there? There's a right here. Okay, does it work? It works. Well, kind of. I mean, well, there are some errors here, but those aren't important for now. Does this work? Now see, it works. Okay, so it's definitely something to do with map buffers. You can't use map buffers and be able to debug your program at the same time. I see. So if we just put the mapping back, the mapping, the writing, the writing, the writing, the unmapping, the mapping. Yep. Okay, is that Googleable? I wonder. Render doc mapped buffers, like, I don't know, crash or something. Yeah, I mean, it's definitely something like this. Gotchas and known issues. Vulkan, yeah, OpenGL. Yeah, well, nothing here says that it should not be able to debug stuff when there is a map buffer involved. Well, I mean, it's gonna be kind of difficult to do anything when is there like a window, event browser, errors and warnings, like, no, that's empty. Statistics, timeline, texture, Python shell, layout, tools, send error report. No. No, I want the log. Where is the... Render doc error log. Debug messages. No, like error log of the actual render doc. What if I launch it from the command line? Is it gonna show me anything that... Where is it located? Let's see. It's like programs, render doc, Programs render doc. What is CMD? UI, so Qt. Why are there so many of them? What's this? It's the same. It's the same. Render doc UI.exe. No, that just immediately exits. Okay, Qt render doc. What's it called again? Render doc. Q render doc. No, that also immediately exits. Okay, render doc CMD. So you can capture, convert, embed, extract. Okay. Projects. Clone. Build or clone.exe. Let's see. So this would be capture. Failed to launch process. Okay, well, what if we just write out the path to it? Ah, there it is. Ah, there's no errors actually. No, this is normal. Like, yep. RenderDoc thinks it's working and succeeding at its task. I see. Okay, well. I guess we're not gonna be using map buffers then? I mean, what choice do I have at this point? Although, I mean, this is so, like, why not? Why do I have to copy stuff around if I can just keep it in one place? Like, the API clearly supports it. It's RenderDoc that doesn't support it. Well, I mean, no debugging for me then? Let's say either no debugging or you have to copy memory around. Because RenderDoc cannot handle map buffers being mapped for like a long period of time or something. I don't even know what exactly is wrong with what I'm doing here. Well, no, regardless of what's wrong. Let's close that. Let's close that. RenderDoc is already closed. Yeah, as it should be. Let's see, what do we got? Got this. We've got that. I moved the unmap up a little. Yeah. Pass camera info to shader. Let's say. All right. Okay. What? G4 experience. Come on. Where does this leave us? Here. So Well, I mean, there is one issue, which is that when this thing is moving, you can kind of see it like jittering around a little bit. I mean, I guess it will be more obvious with. It would be nice to be able to debug these things easier. Well. And the jittering is gonna be a problem because all the art is going to be low resolution. Much lower resolution than the screen. So every pixel is gonna be blown up. And we can't really turn on bilinear because that'll blur the whole thing. So we only want to like blend these pixels that are like on the edge between the pixels. So we can do that. Let's put it to do in here. So I guess in here. Blend the pixels that are in between the pixels. That's one thing. Another thing would be to load an actual texture. And not use just these, like whatever I have right now. These four pixels. Okay, so which one of those are we doing? Well, again, if I'm gonna write actual logic like in here, not being able to debug any of it, like you can't print, you can't examine values. Like, what are you supposed to do? I mean, I guess, yeah. Let's not map them. Let's just return this. Create dynamic buffer. Because it's dynamic. Mappable. So that's just that. The mapped stuff is not happening here. Create dynamic buffer. So this isn't really mapped anymore. This is just like storage, I guess. I guess let's just call it storage, whatever. That works. create dynamic buffer. And well, in this case, the storage could just be just in there. Like, this is not a lot of data. Although in this case, the storage needs to be created on a CPU. And we're gonna have to like map this buffer and copy this stuff in there every time, like idiots. Alright. I mean, I don't know, maybe there's reasons to do it that way, but I haven't seen any, other than that RenderDoc is bad and doesn't support debugging otherwise. Well, let's allocate the storage. Somewhere. I'm just gonna put temporary storage here. Pointer length capacity. Temp storage. Is it 1024? Yeah, it's gonna get removed. And in here, D3, D11, rects, storage, pointer is temp storage. And length is 0, that's fine. Storage. Okay, so it's gonna have to be that, so we set this here. Storage pointer. This has to be storage. Storage. Okay, and now this whole mapping and unmapping business. I mean, the first thing to do would be to map with discard flag, then copy this stuff over, and then to unmap. Okay, and we're gonna have 2 of these. Okay, so the first one is we go in, we map this buffer, yeah. Map write discard. I mean, yeah, I guess discard, sure. So why not? So we map with the discard flag, and then we just do a mem copy. Destination mapped data. Source is D3D11 rects. Storage pointer size is D3D11 rects. Storage length times size of dereference storage pointer. Anything else? No. Destination, yeah. And then unmap. Okay, so map, regs buffer, get this out of it, then copy into it, then unmap, yeah, and do the same thing with the other one. I mean, it's literally just, you know, except that instead of regs buffer in this case, it's gonna be the C buffer. So map, then mem copy, C buffer, and this is just size of that. Something like this. So map copy and map copy and map, then draw. And so all of this now isn't happening. Storage thing. So we just kind of assume that we've copied it at this point. Which means we... Okay, well, hold on. Let's see if this is working right. Well, this is working right. Will RenderDoc deign to let me debug my code? Apparently yes. Apparently now we're allowed. We weren't allowed previously. Now we are allowed. RenderDoc huzzah. Yeah. Okay, let's remove that. So now we don't need to unmap anything. It's only mapped transiently. Any errors? No. No. Are we still capable of... Yeah. Oh, God. Make mapping short-lived to allow for RenderDoc debugging. 7 characters old, yeah, whatever. Alright. Okay, that jittering is annoying, to be sure. But let's make it more obvious by loading a texture. That's more meaningful than that. Okay, we have to draw the texture first. Somewhere, and then load it. Well, do I have a sprite? Let's see. Let's use this here. What's the itch-your? It's all an itch. Logged in, logged in. Yeah, there it is. Yeah, why not? And download. Okay, I have a sprite. Seven zip extract. Move all that there. Now there's the executable. Oh my god. Can it be any whiter? Close. Edit preferences. Dark. Please. Share crash data. Well, sure. Confine user interface to one native window. Yeah, that is what we want. Screen scaling. What if this is 100%? Oh boy. Gotta be an actual hawk to be able to see that. Okay, new file. Width 32 by 32 works for me. Yep. Transparent, background transparent, square pixels, yeah. Oh boy. Ah, so okay, I remember some things. I remember some things. Okay, how do you move things around again? Middle mouse, yeah. Well, we are of course gonna draw something like something structured, something that where we can easily verify that we're loading the correct thing. So let me just, okay, so is this fully red? Yeah, fully red. And then let's go to, there it is. Okay, oh my god, fully, what? Now background colors, like, yeah, that's, okay. It's red, green, fully green, fully blue, wait, no, alpha, yeah. Red, green, blue, and of course, magenta. In the corners, and then something here so we can see the dithering, the jittering easily. So, I don't know, black will do, followed by something that contrasts with it. Followed by something else that's like, yeah, you can draw lines, that's good. Orange, why not? White in the middle of that, why not? Blue, and another black line. Alright. Save that somewhere. New folder data. Sprite 001. Yes, that works for me. Yeah, there it is. Open anyway, what happens then? Text editor, yes. I mean, to be fair, we can kind of read it almost. Okay. Well, now we need to load that. Okay, what is the state of a sprite imports? Import libraries. A sprite import library. Let's see if there's just something we can just use. Okay, well, there's one in Unity, so that, yeah, that makes sense. Do they have a link to that, or community, I don't know, announcements, guides? Well, I mean, this is how to use it, but basics, drawing, selecting file, exporting, sprite sheet, CLI. I mean, I'm guessing there is a way to export into something. Preview, save as. File name. Split layers, ignore, trim. Options, files. Save the last given sprite with other format. What? Ah, so you just give it a... Actually, what are the options for export? Export as... What are the... 5 pixel... Export for Twitter. Animation, direct frames, layers, resize. Is it it's PNG? It's PNG, and that's it. I mean, the A-sprite format basically kind of is a PNG, almost. Partially, anyway. Okay, well, so we can export as a PNG and use STB image to read that, and I guess that would be the least effortful way to handle that. Let's see how that works. CD data there. Okay. Well, I mean, we need to be able to invoke the sprite executable, which means it needs to be in path, unless we want to specify the path every time. Okay, where's my sprite executable? It's in here. Okay, well, I suppose that needs to be added to path. Can we just reload the window and have it be in path? No. We need to launch the whole thing. To launch the whole thing from command line again. Okay, code. Alright. Okay, now it works. Okay, export one layer. Yeah, well, we're gonna get into all of that. Exports. Save. Actually, is there an export? Export tile set. Okay. Dash B. For each frame. On that beta you can specify file name format. Interesting. What was this dash B thing? Batch. Do not start the UI. I mean that, yeah. Asprite dash B, then file name, then save as. Okay, I've got a lot of things open that we don't need that. Do we need that? Save as. Okay, so we're exporting what? Sprite. That what? What's going on here? A sprite dash b sprite dash 001 dot a sprite save as temp png. Oh god. File not found. Oh yeah, because we're not in data. Same as temp.png. So this is in data. Ah. So that worked. There's that PNG file. Red, green, yeah, so that's what I created, yeah. Okay, save as, well, data. 001.png. Yeah, so that's the command we want to run. And for now, I mean, I can just put it in here. And call that good enough. Yeah, that's working. Okay, before we read that in though, I forgot to remove this temp storage stuff. So I want to allocate it. We're gonna need to allocate memory anyway. We've gotten this far without allocating any memory. And now that we need to read files and stuff, we do need to allocate memory. Well, before doing anything else, let's just call virtual alloc. Address size, well, I mean, 1, kilobyte, megabyte, gigabyte. Allocation type, mem reserve, mem commit, file protect, page read write. Void star footer is that. So size, yeah, I just need to kind of save that. I64 size is that. So I'll just pass that in. Assert. And well, that's gonna be an arena, right? Arena is the address of arena. And then arena put parameter, well, I mean, I guess we could just do this, right? Arena base, arena size, assert arena base. Yeah, so before, so this isn't really platform code. Type abstract arena, let's put that above anything. Let's start base, I64, I guess, size, 64 used. Yeah, that's gonna be enough. Allocate it, initialize it, yeah. And then this temp storage thing, well, why are we using it? Here. Arena, alloc, array, arena, then what is it, like rect instance, and then how many? That many. Although, come to think of it, well, I mean, we're gonna need to do it this way. Yeah, let's call that good enough. Okay. So that is the arena alloc static void arena alloc. Well, void star arena I64 size. There's also alignment. Do we need alignment? It's not obvious that we need alignment. Void star. The result is arena base plus arena used. Well, arrows, return result, and then arena, well, I guess assert that arena, I mean, do that right away, assert that arena free size is at least size. Static I64 arena free size arena. I mean, it's gonna be like just return arena use, well, size minus arena used. There's also free pointer. It's gonna be arena base plus arena used. So assert that arena free size is sufficient. Then, like, void star result is arena free pointer and return, well, I mean, arena used plus equals size there. Yeah, alloc array. Alloc array, well, just put it here and define arena alloc array arena type and count. And this would be type star arena alloc arena. I guess let's wrap this. Arena alloc arena, and size would be size of type times count. So that expands to arena alloc arena size of rect instance times storage expected expression. And you didn't get an expression? Is that what you're saying? Can I not wrap the type or something? Yeah. Arena size of and wrap that. I don't know, should I add extra? Yeah, well, can never have enough parentheses. Macros. Do we need alignment? Yeah, I'm gonna have to check that. Okay, well, now, hold on. Now that's not used. This can go back here. Okay, well, it seems to be working. Focus. Okay, well, really I want to just commit this. Stage. Remove temp storage. Temp rect storage. Okay, well, alignment. Might as well check if we can create a situation where reading unaligned data is actually slower than reading aligned data. Just out of curiosity. Can we make that happen? So let's say we've got a bunch of floats. F32, and let's allocate, well, arena free size divided by 2 divided by size of 532. It's just 500 megabytes of floats, let's say. Let's say we have that many. Although maybe we should start with a smaller amount actually. Like 10,000. So if we allocate that many floats, and then, well, I mean, it's zeroed memory. It's zeroed memory. It's not really set to anything. Well, let's I64 float count. Float index. Float count. Index. Array float index equals. Just set it to something like that. So we're writing into the array here, and then we're gonna be reading from the array into the sum. Yeah, hopefully the compiler won't just remove all this stuff unoptimized. Sum plus equals array float index. And at this point we kind of want to output the time that it took, although, well, I mean, I suppose if we're gonna be we're gonna have to compile this unoptimized, so we can't just stop and examine, but I guess for now let's just do it in debug. TSC, can we just call this? Yeah, I think we can. Unsigned long is U64 clearly. Before, after, difference is after minus before. Well, there's that difference, right? That we're sort of looking for. Sum is not used. Oh yeah, we need to format a string here. Well, it's the least effortful way to format a string. Just stbs printf. stb. That'll do. Can we new file? sprintf. Implementation. Well, it doesn't really matter. Well, is this anything wrong here? No, it's all fine. And what is this? Like STB, SP. What are the function names here again? API, STB, SP, sprintf. Well, snprintf really what we want. Is this callable? Yes. Okay. Alright. Buffer, count, and then format string. Yeah. So this is gonna be arena free footer. Count is arena free size. And then the format string test. Char stars, char star out is that, and then just output debug string A. Okay, it's compiling. Okay, well, I'm gonna have to pause it like here somewhere. There it is. Yeah. We can output the string. Now let's format it properly. Tests, was it a little U, I guess, for the diff. Diff and new line diff. Yeah, sum is set but not used. Well, I mean, I might as well just put it in here. Sum %f. And, well, really I want to temp memory this stuff, but man, temp memorying is kind of alright. Let's just start this way. Temp memory. Temp is begin temp memory arena and temp memory arena or temp. Okay, what is our arena code here? Static elements. Type def struct temp memory. It's gonna be i64 used before temp before arena temp count static temp memory begin temp memory. Why am I getting C++ autocomplete? Temp memory temp result. Used before is arena used temp before arena dot static void and temp memory temp memory temp cert temp used before is smaller or equal to temp arena used. Assert temp before is temp arena temp count minus 1. Temp arena used equals temp used before temp arena temp count minus equals 1. Arena temp count plus equals 1. Yeah, I think that should pretty much do it. And let's see. Well, let's go down here, I guess. I must have relaunched. Why not set markers in the arena for partial resets? Well, this used before count in temp memory is a marker. Okay, that's a lot of stuff. Where's my arena? Used. Okay. Yeah, good enough. Is it in the pause there? Yeah. Okay, so we do get the output here. Let's run it more times than just the 1. 4 times to run run index. Okay, now it's gonna run 1,000 times. I don't really want to output 1,000 strings though. Just min max. Min max median, well, average, I guess. Okay, hopefully, can we use min? Are we allowed to use min? I think we are. Well. Make it diff. I mean, this is, we can't, you know what, let's stick with min max. There's the diff. unused sum. Although, if the sum is unused, the compiler might just remove this whole thing, so I kind of have to do something with the sum. Sum of sums. Sum of sums plus equals sum. Min max. Min diff max diff. And use diff. Alright, min diff. Well, we can't initialize it at 0. Uint 64 max. Okay, min diff is min. Okay, so apparently that is defined somewhere. Well, stdlib. Okay. Really? Well, let's find out. Min diff, diff, and then max, similar. Yeah, it is defined. Well, I mean, if it's defined, probably in windows.h somewhere. Okay, what do we get out of that? 164,000, 100,000. So something like that. I mean, okay. Let's see how well this works in optimized. I'll just add 03. Okay, can we even do anything? Like, okay, so it did pause here, so that, well, that's something. 33,000, 71,000. Is that like... Okay, well, the max is all over the place. The min, though, is fairly stable. I mean, it runs pretty quick, so we might as well just increase the times to run. Yeah, max is really wild. Yeah, but the min is around 32,000, let's say. Consistently. Actually, can we step in here and look at what's happening there? We can. I mean, it's a fairly short loop in optimized. Hold on. All right. Well, it's not actually that short, because we just jumped somewhere. Alright. not moving anywhere. That's interesting. Hmm. Yeah, it seems like it unrolled it somewhat. I mean, yeah, but are we gonna be able to examine values? Yes? No? No. Unable to read process memory. Well, yeah, how could you possibly read memory? Yeah, it seems like it unrolled it and it vectorized it. Presumably if we put March native, it will vectorize it some more. Well, let's see, this is still XML, go into disassembly. Okay, so there's the actual loop. It's like, just moved it somewhere. It takes RDDSC, which is, you know, promising. Yeah, well, this is a vectorized loop for sure. Probably unrolled as well. Alright, do we dare run to here? Yes, we do. That's XMM. Okay, so this is like 4 wide? I mean, that does make sense. Somewhat. Alright. Okay, it did not remove the loop. At least, so we are measuring something reasonable. $22,000. Okay, well, March native, right? Okay, so we are around 22,000. What? Okay. So I believe we are, well, I mean, if I put in a certain, that'll mess with it a little bit. But just to verify, we are U64 array. So if I just cast that pointer as a U64, this should be aligned like to 4 bytes at least. If this will check for that. Yeah, so the lower 3 bytes should be 0. Well, didn't mess with it that much. Let's go back to unoptimized, because I want to see the pointer. So array is, yeah, so that is definitely aligned. Okay. Remove that. Now let's misalign it a little bit. Arena used, well, up here. Arena used plus equals 1. That's done only once, right? Are we optimized? We are not optimized. Okay, so we can, alright. So now this array is not aligned to anything. So each float is gonna be like highly misaligned. 03. Okay, well, that seems like the same time to me. So is aligning things just a waste of time? Like that's fine. You know, that's running. 22,000, like very stable 22,089. Okay, let's make sure assert. Array and 3 is not 0. Yeah. It's not aligned. Optimized, optimized. This is aligned. Yeah, it's the same performance. At least with 10,000 floats. I mean, I guess we can change how many floats we are allocating as well. Do another loop. For floats to alloc. It's an array. Let's say 100, 1,000, 10,000, 100,000. Okay, so wrap all of this. Float count. So now this. Where is the float count? Here. Float count goes out. Floats to alloc x. Array count. Do I not have array count? I do. So, what exactly is wrong with this? Oh. Not counting the index. Signed unsigned comparisons, like what? I mean, sure. Okay, float count. We're allocating float count. Let's put here. Float count percent LLU. Whatever happened there? Hold on. Oh, we're not resetting the mins and maxes. And the sum of sums would... Yeah, that should be here. I guess times to run is kind of... Well, what does this tell us? 74, 2,000, 20,000 and 200,000. Yeah, and what if we misalign all of that? Actually, first of all, why are all these git ignores? Like presumably after we end the stamp memory, use should go back to 1, right? Yeah, so we're still misaligned. Yeah. There's your O3. Compiled and optimized. Now everything's misaligned. Okay, well, these are the same timings. Yeah, there's like... This is aligned now. And really not seeing any difference. Okay, well, I guess it doesn't matter then. Might as well just never align anything. If you can just read unaligned, might as well read unaligned. Maybe I should put it somewhere, this code. Call it like bench alignment or something. Void bench alignment. Now we have our debug string, so let's put it in the platform section. Why not? All we really need here is the arena. And let's put an assert at the beginning that arena free footer is, we'll just assume that it's aligned. Did not see any difference in speed with aligned versus unaligned array. angle misaligned. Zoom aligned. Okay, now this can go away. And that to do can also go away. Yeah, anyway, if there is something wrong with this bench, we'll come back to that. It's not gonna be an O3. March native, I mean I should probably leave March native. Might as well have our debug build be as fast as it can be. Okay, that's working. No errors. Okay, what do we got here? Yeah, we're probably gonna need this. Yeah, so it's this that we need to stage. Can I like stage changes like here? Yes. And this. Okay, the others are something else. Quick alignment bench. Oh god. Oops. Alright, so we have that PNG file in here, which by the way, let's just ignore all of those. Sprite I'll probably commit. It's a binary. Hopefully it's not too big a binary. How big is it? 640 bytes. Okay, it's a very small binary. So that's fine. Okay, STB image is what we need. STB image.h. Oh. Alright. New file. STB image.h. So the working directory is the root. So somewhere in here I need to load the texture. And well, I mean I suppose here. And since for now I'm not reloading anything, let's put a to-do in there about that. Make reloadable. Yeah, I suppose we can just do a read file. U32 pixels. Well, I mean, it's an array. Well, I mean, well. Okay, so it's these three things that we need. Okay, so it's gonna be a read file and H file buffer in which to read it. I mean, what's happening right now is we're just reading it, we are putting it into the GPU, and then that's it. Before I forget, let's put an assert here. Arena temp count is 0, and that's enough. What else are we taking here? Buffer, bytes to read, bytes read, and overlapped. Well, buffer is arena. Well, I mean, I guess buffer is pixels, right? Well, no, not yet, not yet. Void star file content and U64 or whatever file size. Sign, like I don't know. File size. Okay, file content. Arena free putter. Buffer, number of bytes to read, file size, so we're gonna have to get that, get file size, H file. Okay, what's EX? So this thing takes a large integer. Yeah, file size, large integer, large, oh yeah, it doesn't actually, integer, file size, it's called struct, get file size, now we need to get the H file, which is create file A. Okay, file name. What's the file name? File name is data sprite 0001 a sprite. Create file. Desired. Oh, yeah, I'm gonna hold that up. Create file A. File name, desired access to generic read is what we need. Share mode, I mean share, read, I don't really care. Share, read, file, share, write, file, share, let's not block it. I don't really care. Security attributes. Pointer, can be null, yeah, that sounds good to me, yeah. Creation disposition, open always, open existing. DW flags and attributes, file attributes normal, yeah. And H template is 0. So that, and that is 1. That is one parameter list. Why is it like that? What's going on there? Interesting. No, it's like they are aligned, it's just they have different lengths of... I see. Okay, well that... oh my god, that should work. Too few arguments. Oh, to read file. Yeah. Oh, file size, quad part. Number of bytes read. Bytes read. LP overlapped. No. Okay, so what's byte read? It's a keyword. Bytes read is file size, quad part. And create file, return value is what? Invalid handle value. Okay, so that should presumably read it in, or not. Interesting, it stopped here. So it stops sometimes when you do things that are incorrect. But not all the time. Only sometimes. So there is the file, content, and size. We have both. Okay, what's STB image API? Oh yeah, we need to include it for one. That will help. Is there an insert in there? What is this? Insert macro ref. Okay, you know what? Let's just like do that. Okay, STB image now compiles. What's the API? I mean, is there a similar thing going on in STB sprintf? No, there's no asserts here. This now fails at any point. I mean, unless... No, it's not case sensitive. Quick notes, yeah. License, revision history, image formats, documentation. Okay, well, there you go. Ah, there it is. Basic usage. Just load from file name, apparently. I mean, is there a load mem as well? I think there's a load mem. There's a load f. Load from memory. Oh yeah, that seems like what we need. buffer, file content, length of the buffer, precisely it's like file size, quad part. Well, let's just go in there and see. Buffer length, is there a documented version of this thing? Primary API works on images of any type, yes. Buffer length, and then return values, desired channels. Default, if non-zero, so like it's optional. The first pixel is the top left. There is no padding between. The first pixel is the top left. Huh. There's no padding between image scan lines or between pixels. Or channels in file. Okay, so I think we can just set desired channels to 0 there. Okay, x, y, so that would be width, and that would be height, comp. Is that channels in file? Comp. In file. So that's in star. And required composition, rec comp 0. Int channels in file. And I guess we can assert the channels in file is 4. Okay, so we're pretending that signed and unsigned integers are different here, so let's change them to signed and really. Okay, what does this return? It returns a void star, presumably, right? Unsigned char star, yeah. Well, pixels equals u32 star. Yeah, alright, well, let's see what that is. So let's remove this. Okay, did it stop at the assert, or yeah, it stopped at the assert. Channels and files 0. Pixels is 0. Yeah, okay. 640 sounds about right. Did it error, or what is this? Like it's incapable of loading PNGs, or what? Return null. Load main. I see. I mean, I suppose I should check for that. And presumably it will stop there now. Yeah. Does it not support PNGs? I thought it supported PNGs. Formats. This was only JPGs. No, it does support PNGs. So Okay, I'm gonna go take a toilet break. And just mute the microphone. Alright. Let's see, maybe I'm just not using it correctly. Maybe I do need to supply 4 here. No. No, it just fails. Okay, interesting. I mean, file content seems to be oh wait, I'm reading the ASprite file instead of reading the PNG file. Well, that does make sense. PNG. It's 186 bytes is what it is. Okay, yeah, so that is correct. Alright. Content bytes read 186, and it seems to have loaded it from memory channels, and file is 4. Yeah. Okay. Just out of curiosity, can we pass a 0 here and have it work? Yeah, we can. Okay. And we're gonna have to free the pixels somehow. is the basic usage again? STPI image free. That's it. And you just pass it the pixels. Yeah. I assume that's just literally gonna call free. Yeah. Red valve from STPI load, yeah. Okay. Make reloadable. Yeah, that's for later. So we have the pixels. We have the width and the height. Actually, let's examine those. Are they correct? Width, height, 32. Both of them are 32. So that seems correct. What's the end result? The end result is this. Okay. Well. Okay, it's upside down. But other than being upside down, it is correctly loaded, at least. So, alright. I think the textures are like bottom up, right? In the API they're bottom up, but the first row here is the top row. So so we're gonna have to move this around. So the bottom pixel actually. Okay, how are we gonna do this? So right now, -1, 1, that's the top left. And that refers to 0, 1. We should think it would be top left. Well, it refers to the top left of the image, but our image is like upside down. So I mean, we could flip the y, right? So you have like this uv dot y times equals -1. Well, actually not -1. Because it's from 0. Hold on, let me just see it again. Alright. So this refers to 0, 1. This -1, 1. Top left refers to 0, 1 in the texture. And, well, we can examine the texture. Hold on. Okay, did it capture? Yeah, it did. Now you want to look at the. There it is. So red is at the top, which is what I did. Red is at the top left. Here, however, red is in the bottom left. Vertex output. Can we take a look at there? VS in, VS out. Yeah, texture coordinates 0, 1. Wait, are the textures... Hold on, if this is the texture the way DirectX represents it... Okay, well, according to RenderDoc, 0, 0 is actually the top left of the texture. Well, if we follow that assumption, 0, 0 is the top left, so 1, 1 is the top right. That would be 1, 0, right? Then minus 1, minus 1, that's the bottom left. That will be 0, 1, and then 1, 1. Okay, red is in the top left, which is where it's supposed to be, in the top left. Okay, well now this is correctly displayed. Alright, another thing I actually want to test is, so let's just find our... Although, well, maybe we don't need to make it reloadable. Okay, dimensions. Let's make the dimensions be... square. Okay, well, they are overlapping. Yeah, this is thrown on top. There it is. Now you can really see the jittering around. So that's good. Okay, if I resize the window, they remain square. Okay, that is good. Okay, so we're kind of, no matter how big the window is, we should be seeing the same amount horizontally, but different amount vertically. And that seems to be working. Okay. Okay, what do we got? Added PNGs here, added an export here, added CV image, added some loading code, yeah, I mean, ideally loading... Although, I mean, I have this to make reloadable, but really, like, I'm not loading the ASprite file itself, right? I'm loading PNG. So, it's not really a make reloadable kind of situation. Yeah, alright. So that's that. Actually, let's see, can we hook this image reading to the arena? Just out of curiosity. STBI Malak, Realak, and Free. Alright, let's do that. Just to see if we can. Malak, Realak. Okay, well, STBI Malak is just arena Alec size, right? Well, actually, Because it doesn't know what the arena. Ah, yeah, we would have to make the arena available for it somehow in order for it to be able to use it. So no, it's not that simple. Right, let's not do that. And what's here? The fixed. All right, it's just this TV image, a sprite. Well, load, add texture. Load a texture. Well, actually, hold on. Another thing. How's transparency doing? Clear. Create. Clear and the target view. Clear it with some kind of color. We want some kind of color. Float color. Wait, is this that kind? Like 0.5? Like, I don't know what color that would be. Yeah. The point is that it's not black. Alright. Transparency is working. We just established. Alright. Load the texture. Commit. Right. What time is it? 16:19. Well, it's gonna be all for today. Thanks everyone.